Before we begin, make sure to subscribe to the channel, like this video, and share it with anyone who wants to understand the technology shaping our future. Artificial intelligence is everywhere today, but have you ever wondered how it is actually created? Is an AI simply programmed to know everything, or does it learn over time? In this video, we'll explore the complete journey of building an AI system, from collecting data to training massive neural networks and finally generating intelligent answers. Artificial intelligence has become one of the most important technologies of the modern world. It powers chatbots, recommendation systems, translation apps, self-driving cars, voice assistants, medical research, image generation, and much more. Every day, billions of people interact with AI without even realizing it. Many people imagine AI as a digital brain that suddenly becomes intelligent. Movies often show computers waking up and instantly understanding the world. The real process is very different. Artificial intelligence is built through years of research, engineering, mathematics, programming, and enormous amounts of computing power. Everything begins with a goal. Before engineers build an AI model, they decide exactly what they want it to do. Some AI systems are designed to recognize faces in photos. Others detect diseases from medical scans, recommend movies, translate languages, or answer questions like a human conversation partner. The goal determines the type of data and the training process that will follow. The next step is collecting data. Data is the foundation of every modern AI system. Without data, AI cannot learn anything. Imagine trying to teach a child what a cat looks like using only one picture. That would be almost impossible. But if you showed thousands of different cats, large cats, small cats, black cats, white cats, sleeping cats, running cats, the child would gradually recognize the common features. AI learns in a similar way, except instead of thousands of examples, it often studies millions or even billions. Engineers gather information from many different sources. This can include books, scientific papers, educational material, websites, publicly available images, videos, audio recordings, software code, and many other forms of digital information. The larger and more diverse the dataset, the better the AI can learn patterns from different situations. However, collecting data is only the beginning. Raw data is usually messy. It contains duplicate information, spelling mistakes, broken files, low-quality images, incomplete records, and irrelevant content. Before training begins, engineers spend a huge amount of time cleaning the data. Incorrect information is removed. Duplicate entries are filtered out. Images may be resized or labeled correctly. Text is organized into consistent formats. This cleaning process improves the quality of the final AI model because the AI learns from better examples. Once the data is ready, engineers design the AI model itself. You can think of an AI model as a giant mathematical machine rather than a database filled with answers. It doesn't store every sentence it has ever seen. Instead, it learns mathematical relationships between words, images, sounds, and ideas. Inside the model are billions of tiny adjustable values called parameters. These parameters are similar to knobs that can be turned slightly during learning. At the beginning, every parameter starts with a random value. The model knows absolutely nothing. Now comes the most expensive and time-consuming step, training. Training means showing the AI enormous amounts of data repeatedly while allowing it to improve its predictions. For example, imagine giving the AI the sentence, "The Earth revolves around the." The AI tries to predict the next word. Maybe it guesses moon. The correct answer is sun. The model compares its prediction with the correct answer, calculates how wrong it was, and then slightly adjusts millions or even billions of parameters. The next time it encounters a similar sentence, its prediction becomes a little better. This happens over and over again. Millions. Billions. Sometimes trillions of times. Each tiny improvement may seem insignificant, but together they gradually create an incredibly capable system. To perform this enormous amount of computation, AI companies use specialized hardware. Normal computers are far too slow for training large AI models. Instead, engineers use graphics processing units, commonly called GPUs. Although GPUs were originally developed for rendering video games, they are excellent at performing thousands of mathematical calculations simultaneously. Modern AI training clusters may contain tens of thousands of GPUs connected together inside massive data centers. These facilities consume enormous amounts of electricity and require advanced cooling systems to prevent overheating. Some of today's largest AI models require weeks or even months of continuous training before they are ready for use. One of the biggest breakthroughs in artificial intelligence came from a technology called the transformer architecture. Earlier AI systems processed words one after another in a limited sequence. Transformers changed everything. Instead of looking at only nearby words, they examine relationships between all the words in a sentence at the same time. This allows the model to understand context much more effectively. For example, consider the sentence, "The trophy didn't fit into the suitcase because it was too small." What does it refer to? Humans immediately understand that the suitcase is too small. A transformer analyzes the relationships between all the words and learns these kinds of connections through training. This ability to understand context is one reason modern AI systems feel much more natural than earlier generations. As training continues, the AI starts recognizing increasingly complex patterns. It learns grammar, sentence structure, programming languages, mathematical formulas, scientific concepts, writing styles, historical information, relationships between ideas, cause and effect. It doesn't truly understand these topics in the human sense. Instead, it becomes extremely good at predicting patterns based on everything it has learned during training. Once the initial training is finished, the work is far from over. Engineers begin testing the model. Thousands of questions are asked. Coding challenges are solved. Reasoning tasks are evaluated. Language understanding is measured. Safety tests are performed. Weaknesses are carefully documented. If the model makes mistakes too often in certain areas, engineers improve it through additional training or fine-tuning. Fine-tuning allows developers to specialize a general AI model for specific tasks. For example, one version might become better at medical research. Another could specialize in programming. Another could focus on customer support. Another might become an educational assistant. This customization makes AI much more useful across different industries. After training and testing, engineers optimize the model for speed and efficiency. A fully trained model can be extremely large, sometimes requiring hundreds of gigabytes or even more. Various optimization techniques reduce memory usage and increase response speed without sacrificing too much accuracy. The optimized model is then deployed to powerful cloud servers. This is why you don't need an expensive computer to use AI. When you type a prompt into an AI chatbot, your request travels across the internet to data centers containing powerful hardware. The AI receives your message and begins processing it. First, your sentence is broken into smaller units called tokens. These tokens are converted into numbers that the neural network can process. The transformer analyzes the relationships between every token. It predicts the most likely next token. Then another. Then another. This happens incredibly quickly, often dozens of times every second. Word by word, sentence by sentence, the AI builds a complete response based on probability, context, and everything it learned during training. A common misconception is that AI searches the internet every time you ask a question. In reality, many AI models generate answers from the knowledge learned during training rather than performing a live web search. Some AI systems can combine both trained knowledge and current online information, depending on how they are designed. Today's AI is used in almost every major industry. Doctors use AI to analyze medical images. Scientists use it to accelerate research. Engineers design products faster. Programmers generate and review code. Students receive personalized tutoring. Businesses automate repetitive tasks. Artists create new digital artwork. Filmmakers generate visual effects. Musicians experiment with new sounds. Researchers discover patterns hidden inside enormous datasets. Every year, new applications continue to appear. Researchers are now building multimodal AI systems that understand text, images, audio, video, and even robotics at the same time. Future systems are expected to become better at reasoning, planning, scientific discovery, and assisting people with increasingly complex tasks. Even with these advances, AI still has limitations. It can make mistakes, misunderstand questions, produce outdated information, or generate confident but incorrect answers. That's why human judgment, verification, and responsible development remain essential. Artificial intelligence is not magic. It is the result of mathematics, programming, massive datasets, powerful computers, and years of engineering. Behind every AI response are billions of calculations performed in fractions of a second. Now you know how AI is created, from collecting enormous datasets and cleaning information, to training neural networks with powerful GPUs, testing performance, optimizing the model, and finally generating answers one token at a time. Thank you for watching. If you enjoyed this deep dive into artificial intelligence, subscribe to the channel, leave a like, and share this video with someone who wants to understand the technology behind modern AI. See you in the next video.